So funny thing, I was setting up hotkeys because I'm always using my mouse and clicking the pause recording button, clicking the stop button, and I decided to set up some hotkeys, and I got them round the wrong way. So like I wanted to pause recording and restart again. I accidentally pressed the stop button. So now I know I can combine the videos together, but I won't because it's funnier this way and less effort. Now here what we got up to. We're finding the area of the barn for part A, and we go straight to the surface area. It's two lots of the number 1, which is a rectangle, 2 by 2.4, plus, I'll go across because there's not much room, two lots of number 2, that's a triangle, it's half times the base across is 2.4, but what's the height? Well, if it's top to bottom 3.5 and that's 2, that has to be 1.5. And that should be straighter. That should be straighter just because the height, it's perpendicular height. It's got to be like that. 1.5. 1.5 meters just for the triangle. So it's 2 times that times 1.5. Plus number 3, two lots of 4 by 2. Plus two lots of, we've got to be careful here, it's 4 meters long and 1.9. 4 times 1.9. I'm going to save us all some time. That's 4.8 times 2 is 9.6. 2.4 times 1.5 is 36. 2 times 8, 16 there. And then that's 3.6, 7.2. There's 4 things to add up there. The multiplying is the easy bit. The addition takes longer. It takes way longer. Maybe I should learn to do it while I put stuff in the calculator. That 9.6. That was 7.2. 9.6, 7 plus 2, 16.8. Add another 16, 32.8. This way is not bad. 32.8 plus 7.2. I've already forgotten. Was it 16 point? I forgot. Plus. Yeah, I forgot. I don't know if that's right or not because I forgot what I was doing. 44.4. Man, I have to learn how to add things in my head. Multiplying is easier. So we got meters squared. Okay, so here's the second bit. I got to speed up. Video's going on for too long. 1 liter of paint covers 10 meters squared. How many liters are going to be required? Well, 4 liters would give us 50. 4 liters would give us 40 meters squared. So 5 liters would give us 50 meters squared. So if we're buying the tins, we got to, in 1 liter at a time, we got to buy the 5. But we can do better than this. What we can do is do 44.4 and divide that by 10, and you'll get it. Got 4.44. Because this is how many lots of 10. So 4.4 lots of 10. So therefore you need 4.44 liters. That's the logic. And you can't even see that. Can't see that either. Oh dear. Oh, I'm not doing too well. Stuff you can't see. Pausing stuff. I'm just going too slowly. Classroom. I want you to have a go at that, and then when unpause properly, answers. So I'm halfway through the answer. I decided I should stop here, and before I keep going any further. So the part A found the area of the floor, which is just the 10 by 8, and each square meter costs $105. And then you got 80 of them. So 80 lots, 105. That's part A. For part B, you have to find the area of the walls and the ceilings, but got all these doors and windows. And we're not going to paint the doors, well, at least not in that color. And we're not painting the windows. So we got to take away the windows and the doors. So what I do it in multiple steps. First, find the area of the walls and ceilings, which I said was 188. And then we're going to find the area of the 4 windows and the doorway. And then we're going to subtract them. So the 4 windows and the doorway, it's 4 lots of windows are 2.5 by 1.5. And then add a doorway. 2 by 0.8. And it's just one of them. So that, 4 lots of that, blah, blah, blah. So I need to do some stuff in the calculator here. Make sure I got the first one right. 2 by 8 times 3. I'm leaving out the brackets to save time. Plus 1 lot of 8 by 10. Good, got that right. So 4 lots of 2.5 by 1.5. Ooh, trick. 4 lots of 2.5, that's 10 times by 1.5. So that's 15 plus 1.6, 16.6. I thought it'd be too hard. Gotta find the tricks. And then, so we got the total area and we take away the windows and the doors. So the painted area, 188, take away the 16.6. Which is, so what I'm doing, take away the 10, 178, take away the 6, 172, take away 0.6, 171.4. You know that method you're taught where you go, ooh, 188, and you take away 16.6, and oh, I better put a 0, then no one ever does that. It's actually really silly. It's not the way you do things quickly. It's slow, it's tedious. You learn like that much doing it. Okay, scrolling down. Man, my video's going on for too long. I have too much fun. Now this one is a little bit tricky. But I'm going to show you what to do, but you're still going to do it. So PQ, we don't know it. But if you look, if I drew that line there, I'll make that even easier to see. I can make it solid. Why not? We have a right angle triangle there. This is 15 meters. And this bit, 3 meters is from there to there. I don't want that. I just want that bit there. Well, that's 1 meter. We know that. So it's got to be 2. So what we have, the PQ, if I just redraw it, less ugly. Well, that's still messed up, but whatever. 15 meters, 2 meters. I need to find PQ. So how do we find PQ? Pythagoras is our friend here. And it's going to be something plus something equals something. For Pythagoras, A, B, C, it's A squared plus B squared equals C squared. We got the A's and B's are the short sides. It's 15 squared, I know is 225 plus 4, 229. C squared, C is the square root of 229. Oh, I won't swap sides. That might confuse some people. 229 equal to C. So now, just at the end, I'll swap. Now, that's not going to be perfect. It's going to be like 15.08. I made that up. I totally made that up. Square root of 229. Wow, it was over 1. 15.13. See, what is it? I'm taking guesses here. Over time, I'll get better. I plan to teach maths for a while, so I'll get better eventually. So that's the first one. We got PQ, and I said 1, 3 to 2 dp. That's enough detail. You don't need all those numbers. All right. After we've got PQ, and I was meant to make you do that, but I did it for you. Now we can find everything else. The area of the floor of the pool, we can do that. The area of the 4 walls, 1, 2, yep, can do that. And the total surface area of the pool, yeah, we can do that too. All right, have a go at BCD. I'm going to pause now, not stop, pause. So, done the floor. done the four walls. The floor is that slanted bit there, so we had to use the PQ, and then we had to times it by the 10. So if that's 10 there, it's 10 wide, that's 10 there. So that's PQ, which was our 15.13 times by 10. So that was that one. The four walls. The left one was just 10 by 3, the right one by 10 by 1. But the front and back were trapeziums. They're the same. So find the area of trapezium and double it. We needed the formula of a trapezium. Down the bottom left here, half height A plus B. And the tricky thing is the height now is actually that sideways bit, because it's the height between the parallel lines. Like normally I'll do it in red over here. A trapezium looks like that. Or maybe like this. And now height there. But now we have to just turn it round sideways. And the height now is that way. Weird, right? But whatever. So that's just leave some little drawings up there to help you out. Anyway, and then we didn't actually have to use that PQ at all for that. Not for that formula. So now the total surface area of the pool. We've got the floor. We've got the four walls. Do we need the top? That's the question. You're thinking, oh, do we need to add this top surface? And think about it. This is a real world problem. It's a pool. When you talk about the area of your pool, no, there's nothing there. That's where the water goes in. We only care about the four walls and the bottom. We just need to add, we just need to add the floor plus the walls. That's all we care about. 151.3 plus 100, 251.3. And we're done. Sorry, video went on for too long. I got to speed things up. Bye. Hotkey.